Hello all. Today we discuss about the statistical mechanics problem, statistical physics, and first of all we discuss in this class the probability, the different types of sums are related to the probability. So our first sum is find out what is the probability of drawing a king from a pack of 52 cards. From a 52 card means there are 52 cards available in card playing game. Now as the pack has 52 cards, the total number of equally likely possible ways is n equal to 52. Okay, there are 52 equally likely ways. There are 4 kings, okay, and we wish to draw any one. So total number of way favorable to the event. So total number of way. So total number of ways which is favorable to the event. The event is to choose the king. That is 4, because there are 4 color. Therefore probability P equals to the number of ways favorable to the event n m and total number of equally likely ways possible. That means 4 by 52. That means 1 by 13 is the probability of drawing a king from a pack of 52 cards. And okay, and next one is a card is drawn at random from a well shuffled pack of 52 cards. So find the probability of getting 2 of hearts of diamonds, 2 of hearts or diamonds. Okay, so now in the second problem there is also n equals 52. That is total number of ways, total number of equally likely possible ways n equal to 52, and there is 1 2 of hearts and 1 2 of diamonds, and we used to have any one of them, then the number of ways which is favorable to the event, that is m equal to here 2, not 4, because there are favorable event m equals to 2, because there is 1 2 of hearts and 1 2 of diamonds. So therefore probability P equals to m by n. So this is also equals to 2 by 52. That means the probability equal to 1 by 26. So this is our first problem related to the card playing game. So in a card playing game, this type of problem arises to draw the king, and when each card is drawn at random from a well shuffled pack of 52 cards, find the probability of getting 2 of hearts or diamonds. Now in the next problem we discuss that if a pair of 6-faced die, we consider a 6-faced die, 6-faced die. In a die there are 6 faces, 1 2 3 4 5 6, marked as a 1 to 6 is thrown, then calculate what is the probability that the sum of the number which shows up is 8. Okay, first of consider here one thing is that if a pair of 6-faced, that means there are 2 pairs, that means there are 1 6-faced surface cube, this is first and this is another second. Okay, 2 cube, because in the problem mentioned that pair of 6-faced die with faces marked 1 to 6 is thrown, then what is the probability of sum of the number which is shows up 8? That means either this is 6 and this is 3, either this is 3 or 6, or this is 5, this is 4, or this is 4, this is 5. There are lots of probability of getting out. So now when we throw 2 dice simultaneously, then first dice can fall in n1, that is equal to 6. There are 6 ways with any of its face mark for 1 to 6. Okay, there are 6 possible ways. Corresponding to each of these ways, the second dice can be fall up for the same, for the second die n2 equal to 6, because there are 6 surfaces. So therefore total number of different ways equals to n equals to n1 into n2. That means 36 different ways in which 2 dice can fall. Therefore total number of equally likely possible ways n equal to 36. Now the sum of the number which shows up will be 8 for the following combination. So here we consider one table for first dice and this is for second dice, and here total therefore this is 2, this is 6. Say consider the first dice equal to 2 and then therefore the sum equal to 8, and consider for 3 this is 5, this is also equal to 8, this, then 4 and 4 this is also coming out, the summation equal to 8, then 5 3 this is also 8, and last of one this is 6 2 and this is also 8. So there are no other combinations possible, so there are basically 5 combinations are possible, which shows summation equal to 8 when 2 pair of 6-faced dice will thrown. So now here the number of ways favorable to the event, that is m equal to 5. There are 5 events, so hence the probability equal to, so there is a formula m by n, that is 5 by 36. Okay, so these are the probability. Okay, now our next problem is that two 6-faced dice are thrown simultaneously. So now list the various ways in which the event can happen and what conclusion do you draw from it. Now throwing of 2 dice. Now our problem is that there are throwing of 2 dice. Okay, so if we throw 2 dice simultaneously, then the first die can fall in 6 different ways corresponding to the each of these ways. The second die can also fall in 6 different ways. So there are number of different ways in which 2 dice can fall simultaneously. That means 6 into 6. Therefore this is 36. Okay, so there are 36 possible likely ways. Okay, this first comes out. So these ways are different ways are 1, 1, then 2, 1, then 3, 1, then 4, 1, 5, 1, and 6, 1. So 1, 2, 3, 4, 5, 6 different ways. Now for the second, 1, 2, this is 2, 2, this is 3, 2, this is 4, 2, this is 5, 2, this is 6, 2. Okay, now this is for 1, 3, this is 1, 4, 1, 5 for column wise, 1, 6. This is now 2, 3, 2, 4, 2, 5, 2, 6. This is 3, 3. This is 3, 4, and so on, and so on, and so on. So last one is 6, 6. Okay. So from the above example, we conclude that if one event can occur in n1 different ways, and another independent event can occur in n2 different ways. Independent, why? Because 2 dice are thrown separately. No one event is dependent on the another event. Then the both events can occur together simultaneously into n1 into n2 different ways. That's why there are 6 rows and 6 columns. That is 36 possible combinations. Okay. When 2 6-faced dice are thrown simultaneously, so there are total 36 number of ways this possibly comes out. Okay, now we discuss about the another problem. A bag contains 5 white balls and 6 black balls. Okay, note down, a bag contains 5 white and 6 black balls. 3 balls are pulled out of the bag one by one in a random fashion. Then find the probability of all the balls to be white. Okay, this is the first problem. So first task is our number of white balls equals to 5, number of black balls equal to 6. So total number of balls equal to 11. So therefore probability of first ball to be white, this is 5 by 11, and probability of second ball to be white, this is equal to 4 by 10, because one value is minus from the first, and the probability of third ball to be white, this is 3 by 9. Since 3 events are independent, Okay, so according to the multiplicative law of probability, the probability of all the balls to be white, that is 5 by 11 into 4 by 10 into 3 by 9, that is equals to 2 by 33. So these are multiplicative rules. So the question is that in the problem that 3 balls are pulled out of the bag one by one in a random fashion, find the probability of all the balls to be white. So that's why here we calculate the first ball to be white, second ball, and then third ball. So this is the probability of first ball to be white. This is the probability of second ball to be white. This is the probability of third ball to be white. Okay. Now the second question is that from a well shuffled deck of cards, what is the probability that 3 cards drawn in succession are all aces? Now we know that there are 4 aces and the number of ways possible to the event, that is the card drawn may be, therefore for the card problem, therefore the number of a favorable event equal to 4, and there are total event equal to 52, therefore probability equals to this 4 by 52, that is there are probability of 1 by 13 of aces are coming out of this 12 probability, and this is the first probability, and therefore the number of ways in which the second card will be drawn, therefore n equal to 51, therefore, and because after one card has been drawn, the number of card is left equal to 51, because one card we drawn, therefore 52 minus 1, that is 51. So assuming that the first card is favorable, that is in an ace the number of aces left in the pack is 3, therefore the number of ways favorable to the second event, that is the second card draw, may also be as equal to 3. It is not equal to 4 because first aces will be coming out, therefore in the second case the probability equal to 3 by 51, that is 1 by 17. So now total probability equals to 1 by 13 for coming out the first aces, and for the 7th aces this is 1 by 17. So the total probability 1 by 2 to 1. Okay. Now after the second card is drawn, the number of card left is 50. Now from the third cases, therefore there are 2 aces are remaining. Now for the probability equal to 2 by 50, this is equal to 1 by 25. Now what is the total probability? Total probability equal to first probability, second probability, this is a multiplicative draw. So first probability is 1 by 13, 4 aces out of 52 cards drawn, therefore then 3 aces are remaining, the total number of card equal to 51, this is equal to 1 by 17, and then 2 out of 50, that is equal to 1 by 25. So therefore total probability equal to 1 by 5525. Okay, so this is our answer. So probability of different probability and their multiplicative laws are applied here. Now the third problem is that what is the probability of drawing 2 king in succession from a pack of cards? 2 king. Okay, therefore first probability of the king getting the king in the first draw, that is equal to 4 by 52, because there are 4 king and 52 favorable, 52 events are possible. Now for the second king, this is the first king. Now for the second king, this is equal to 3 and this is equal to 51. Why? Because already one king is coming out, therefore 4 minus 1, 3 kings are available, and total number of favorable and total number of cards equal to 52 minus 1, that is 51. So that is 1 by 17, and then the third king available is for 2 by 50, this is also 1 by 25, and so on. But our question is that what is the probability drawing of 2 kings in succession? So therefore the probability of 2 kings, that is this is first and second, will be considered here. Therefore the probability of drawing 2 kings in succession, that is equal to 1 by 13 into 1 by 17, that is equal to 1 by 2 to 1. So this is our answer, and this is the probability of drawing 2 kings in succession from a pack of cards. Okay. Now our next problem is that consider our next problem is that three similar dice marked as ABC. Consider there are three dice marked as ABC, each having a 6 equally likely faced 1, 2, 3, 4, 5, 6 are thrown simultaneously. Now calculate the probability of getting the face of all the dice uppermost marked with number 1. So now we marked number 1, should be minded. So our problem is that calculate the probability of getting the faces of all the dice uppermost marked with number 1. So now probability, and the answer is, so now the probability of first die A to show the marked 1 up, that is P1 equal to 1 by 6. Then probability of the second dice B to show the face marked 1 up is also equal to P2 equal to 1 by 6. And for the third, the probability of the third dice, that is C, to show the marked 1 up, that is equal to also 1 by 6. So now probability that all the three dice ABC show the face 1 up, that is equal to, again we apply the multiplicative law, P1 into P2 into P3, that is equals to 1 by 6 into 1 by 6 to 1 by 6, that is equal to 1 by 2, 1, 6. This is the probability, total probability, which shows when three similar dice marked ABC are marked with a 1, 2, 3, 4, 5, 6, then this is the probability of 1 by 2, 1, 6 is the probability of getting the faces of all the dice uppermost marked with number 1. Okay, so this is our problem. Now we discuss another problem. There are lots of problem in the probability. Now two 6 faces die, consider two 6 face die, each marked 1 to 6 are thrown. The calculate the probability that one of the dice shows 6 and another is shows 5. So now our problem is that the first die can fall in 6 different ways with any of its face marked 1 to 6 upward. Out of these, only 2 ways are favorable to the event, that is when the dice falls within the face marked 5 or 6 upward. So okay, this is a very easy task, that for the dice there are 6 surfaces, but our problem is shows that calculate the probability of dice, probability of one of the dice which shows 6 and another is and another shows 5. So there are 6 probability, but we only shows the 5 and the 6 upward. So probability that the first die shows 5 or 6, that is probability of the first dice which shows the dice shows 5 or 6, that is there are 2 event and 6 number of ways, that is equal to 1 by 3, that is 3.3% probability will be occurs for the first. Now probability that the second dice must shows 1 out of 5 or 6 which is the first dice has not shown. So this is equal to probability equal to P2. Okay, because these first dice cannot be shown. Here one thing mentioned that the second dice can also fall in 6 different ways, but out of this way only one way is now favorable event. If the dice falls with 5 out upward, the second dice must show 6, and if the first die fall with 6 upward, the second dice must show 5. So that's why here the probability the second die must shows 1 out of 5 or 6, which is the first dice has not shown. That's why here 1 by 6. So now what is the probability? Now the probability that one of the dice shows 5 and other shows 6. Therefore we again here apply the multiplicative law, that is 2 by 6, there is 1 by 3 also. So this is answer equal to 1 by 18. So this is all the probability. Okay, this is the probability. Okay, there is another law in the probability which is known as Additive Law of Probability. So now what is that? Additive Law of Probability is very interesting. The law is applicable to mutually exclusive event. What is law? 2 or more events are said to be mutually exclusive if the occurrence of any one of them prevents the occurrence of the others. So this is very important. I again repeat, 2 or more events are said to be mutually exclusive if the occurrence of any one of them prevents the occurrence of others. such events never occur simultaneously. Consider two events which are mutually exclusive. Suppose there are n total number of exhaustive, mutually exclusive and equally likely ways in which the event can happen, out of which m1 are favorable to the first event and m2 is a second event for the second event. Then as the events are mutually exclusive, then the number of ways in which either the first or second event can be happen is given by, this is the formula. So total m equals to, this is m1 for the favorable for the first event, this is m2 for the favorable for the second event. Now probability of occurrence, now p1 is the probability of occurrence for the first event, that is equals to p1 equal to m1 by this is n, and probability of occurrence of the second event, that is p2 equal to, this is also equal to m2 by n. Then the probability of occurrence of the first or the second event, p equals to m by n. So this is the total, therefore this is m1 plus m2, same, and this is also m1 by n, m2 by n, and m1 by n. So therefore this is also equal to p2 plus p1 or p1 plus p2. So this is a law of additive law. If there are more than two, say k number of mutually exclusive events and their probability of occurrence equal to p1 to p2 3 the p1 p2 p3 dot pk, then the probability of occurrence equal to p equals to p1 plus p2 plus p3 plus dot pk. This is known as additive law of probability. Okay, so now one example is shown for this additive law of probability. Suppose a card is drawn from a well shuffled pack of 52 cards. Calculate the probability this card to be either king or queen. So there are 52 cards, so therefore the total number of ways in which the event can occur, therefore n equal to 52, therefore small n equal to 52. Small n is also known as total number of ways in which the event can occur. Now we used to draw a card which is king, so we know that in a card there are 4 different colors of king are available. So therefore first favorable event m1 equal to 4. Now therefore probability of drawing a king, that is equal to, very simple, m1 by n, that is equal to 4 by 52, that is equal to, coming out 1 by 13 is the probability. Now there are again 4 queens in the pack of cards, therefore the number of ways in which the second event, that is the drawing of a queen, may happen, that is for the second event there are 4 different colors of queen are available, that is equal to 4. So now what is a p2? p2 equal to m2 by n, that is also equal to 4 by 52, that is also equals to 1 by 13, this is 52. Okay, now the events are mutually exclusive because the occurrence of the one prevents the occurrence of the other. Now the probability that the card drawn either king or queen, okay, that is equals to p1 plus p2 total probability, so that is equal to 1 by 13 plus 1 by 13, that is equal to 2 by 13 is the total probability. The probability that the card drawn is either king or a queen. And one thing should be remember, the events are mutually exclusive here because the occurrence of the one prevents the occurrence of the other. This is very important, okay, because we shuffled in a pack of 52 cards, and these 52 cards, within these 52 cards we find the probability of drawing the king and probability of the queen. Okay, now we discuss about the concept of permutation and combination. So what is a permutation? The word permutation means the arrangement, and the word combination means the formation of groups. Okay, number two, suppose we have 4 distinguishable objects. Suppose we have a 4 distinguishable object marked as A, B, C and D, and taking any 2 objects at a time, these can be arranged as a taking 2, okay, AB, BA, AC, CA, AD, then DA, then BC, CB, then BD, then DB, then CD, then DC. So basically there are 12 arrangement, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 arrangement in all. Okay. In arranging these objects in order of their placing is also taken into consideration. Thus AB and B are 2 different permutations. So we say that 4 objects can be arranged in a 12 different ways by taking 2 objects at a time, or a number of permutation of 4 objects taken 2 at a time is 12. I can repeat, the permutation of 4 objects taken 2 at a time is 12. Symbolically, it is represented by the formula 4 permutation 2, that is equal to 4 factorial divided by 4 minus 12 2 factorial. 4 factorial means 24 and this is 2 factorial, so the answer is 12. So this is called the permutations. Similarly, for the 3 objects, now we're taking the 3 objects at a time. So what is a permutation? 4 permutation 3, that is equal to this and 1 factorial. So there are 24 different ways are possible of permutations. So the different arrangement which can be made out of a given number of distinguishable objects, taking some or all at a time, are called permutations. Okay, this is very important definition for permutation. Now it is found that the number of arrangement of indistinguishable object by taking r, this r, there are small r at a time, therefore the permutation formula is npr. So this is a very famous rule. Therefore this is equal to n factorial divided by n minus r factorial. Okay, now what is a combination? The combination is basically, the combination is, what is a combination? The combination is basically, just a minute, okay, the combination is a form of group of object without taking into consideration the order of their placement. Thus the combination of 4 objects A, B, C, D is taken 2 at a time, that is the combination of 4 objects taken 2 at a time, that is AB. First of all, AB is a combination, then AC, then AD, then BC, then BD, then CD. So you can repeat that the combination of 4 objects ABCD taken 2 at a time are taken 2 at a time AB, AC, AD, BC, BD, CD. Thus there are 6 combinations. So symbolically it is represented by 4 combination 2. That is, the formula is 4 factorial divided by 2 factorial and 4 minus 2 factorial, that is equal to 24, that is equal to 2 into 2, that means equal to, this is equal to 6. So now similarly, when combination of 4 objects ABCD taken 3 at a time, therefore there are only 4 combinations are possible, because 4 combination 3 taking 3 at a time. So the different groups which can be made out of a given number of mutually distinguishable object by taking some or all at a time, such that the order of their placement is not taken into account, are called combination. And there is a formula of combination, that is NCR, which is equals to n factorial divided by r factorial into n minus r factorial. So this is the formula of combination. So the definition of combination is that the different groups which can be made out of a given number of mutually distinguishable objects by taking some or all at a time, such that the order of their placement is not taken into account, are called combination. Okay, so this is the importance of combinations and permutations for calculation in the statistical analysis.